have your workbook out. You're just going to self-mark to see, make sure that you understand and that you're on the right track. Please ask questions if you did not get it right and you don't know why. So I'll just talk about it briefly together, okay? So around oxygen, you should have 6, 2 being lonely ones. Lithium has 1, chlorine has 7, strontium has 2, sodium has 1, and it doesn't matter where your dot is, as long as you just have 1. Magnesium 2, phosphorus 5, selenium 6, bromine 7, radon 8, because it's a noble gas, it's all full, and francium 1. Now, I don't know if I've actually talked about this yet before, but what is it called when they're together? Do you know what it's called when they're together? No? A pair of electrons, something like that. It's called a lone pair. Yeah. And what is the one, if it's not in a pair, called?
Just a lone.
No, the whole thing is an element. Okay, so this, can I draw on this? Okay, so when you have them together, like that, okay, it's called a lone pair. When there's just only one, it's called a bonding electron. That's important for you to know. I forget that I haven't told you things like that. So if it's ever together, lone pair. So things like on chlorine, this would be a lone pair. And then this one would be a bonding electron. Okay? All right. So here, this table, can you see, is it too small? Is it okay? Can you guys see the back? So this table should have been fairly straightforward to fill out because it was organized by groups, right? So everything in this group would only have 1. Everything in this group has 2. Everything here has 3. Carbon and silicone have 4. Nitrogen and phosphorus 5. Oxygen and sulfur 6. Fluorine and chlorine 7. Helium, neon, and argon 8.
Helium only have 2?
Yeah, oh, sorry, yeah, helium 2, argon, and neon 8, yeah. Okay, so now I'm going to read to you my answer for number 6, and I want you to look at your answer and see if you have to add anything. So it doesn't have to be exactly how mine was, but as long as it's something kind of like it. So just listen. So, helium only has 2 electrons in total, right? And the first energy level can only have 2 electrons. Therefore, helium's valence electron shell, or orbit, is full, meaning that it's stable. So that's why I compare them together. So the really important thing that you need to have in your answer is that helium is stable. Okay? It's stable, its valence shell is full. That's the really important thing. Helium's valence shell is full, meaning that it's stable. So that's why we draw them in a pair, a lone pair. We don't draw them as separate bonding electrons because helium doesn't have a bonding electron because it's a noble gas. Okay? Any questions about that? So yours doesn't have to be the exact same. And I am videotaping this, so if you want to go and kind of listen to me explain it again, you can. Okay? Right. So let's talk about these definitions. Again, you don't have to have the same thing as me, but I'm going to tell you what important things need to be in yours. Okay? So, you know, this isn't, like your workbook it in class like we are right now, I'm not going to take it in for marks, so you shouldn't be like randomly scrambling to finish it, because I'm not going to like penalize you for it right now. I want you to make sure that you understand it. That's the point. So if you don't, please say like, oh, but I had this, or whatever. Okay, so an ion. What is an ion? It's the result of a neutral atom either giving away or taking electrons. So it's what happens after an atom has given away or taken electrons. Do you want to, what else did you guys have?
I said it has
No, go ahead.
well, I said it's positive and negative charge.
Yeah, that's a characteristic of it. It has a positive or a negative charge. So say on a test I want you to tell me what is an ion. I want you to tell me though too how it became an ion. Okay, so it became an ion because an atom gave away or took an electron. So the exchange of the electron is the important thing. So then a cation, a lot of you just wrote down, I looked at some of your workbooks, you might have just said positive ion. Yes, you're right, but tell me more. Well, how do I get a positive ion? Well, metals, they become cations by losing electrons. Okay, so it's the loss of electrons, so that's really important. And then an anion is the opposite. Yes, it is a negative ion, but tell me more. How did it become a negative ion? Well, it gained electrons. Then an ionic bond is the attraction between that positive and that negative. Okay, so the ionic bond is the attraction between the positive ion and the negative ion. Now, the ionic compound, which we're going to have a quiz soon, this question will be on your quiz. First question. What is an ionic compound? It is the result of a cation and an anion bonded together by an ionic bond. So that was like when we had Braden and Alicia up here, and one of them was a cation and one of them was the anion. They were separate until Kyle put in an ionic bond. Now they were linked and they became ionic compound. They were separate before, then they became together, an ionic compound. That's a simple answer. Yep, go ahead.
I put something different. I put like their stabilized bonds.
Okay, good. Yes. This definitely makes a stable compound. That's a great thing to add. Yeah. Add something more about the stabilized bond. Say it's, the stable bond is the ionic bond, right? And where did it come from? From the cation and the anion coming together. But that's a great point. This is it makes stability. That's a great addition. Thank you. Then yesterday, now we can answer the last question because yesterday we talked about this. How do we name an ionic compound? Well, the first part is writing the cation, and then the second part is writing the anion with IED at the end. IDE, not IE. That's okay. Okay. Try and get down as much as you have your workbook. Okay, so now a lot of you have kind of showed me yours, and I've kind of checked over this with you, but I just want you to look at yours, look at mine, and see they should be the same, so let's just talk about them. So we have our lithium and chlorine. Lithium gives 1 to chlorine. I end up with lithium with a positive charge and chlorine with a negative. And I get LiCl, lithium chloride. We can add, I know I didn't say you had to put the name, but we can now because we know how to name it. So this one we end up with 3 strontium. Each of them give away 2 electrons. Your arrows can point to different spots than mine, just as long as you have 3 strontium, each giving away 2. And you have 2 phosphorus, each giving away, or receiving 3. Oh, and I didn't write my thing here. So it should be SR3P2. Strontium phosphide. And then you have your potassiums, 2 potassium, each giving away 1. 1 oxygen receiving 2 potassium oxide. And then the back page. Any questions so far? Too fast, too slow?
I have a question
Yep.
about like writing the dots. If it has 6, you have to leave 2 that are that are not alone here. Can you put them together?
When you have 6
When you have
electrons?
6 electrons, like you have to write it so that there are 2 by themselves and then write it.
So,
She means like you put like 2 on the top, 2 on the bottom, and 2 on the side.
oh, like that?
Yeah, or can you put like the other 2 that are by themselves together?
Oh,
Like
this?
no.
Here, maybe you just
Move from one dot to the other dot.
like this?
Yeah, and then
No.
No?
No.
Okay.
No. No, because that implies. Okay, so maybe I should do this on the board so everyone can see. So the question was, can you write, say you know oxygen needs 6, can you write it like that? No, because what I was just saying earlier, having them together, that means that these are lone pairs. Writing it like this means there's no bonding electrons, but that's not true. There's 2 bonding electrons in oxygen. So representing it like this shows that there's bonding available. Yeah, that's a really good question. I never thought of that before.
That's why pure oxygen is only 2.
Yes, because it can't exist by itself. Yeah, well, and that's for molecular compounds. We'll get into that later. That'll get fun too. But yeah, because it needs 2 spots, so you need 2 oxygen atoms. That's molecular. That's something different. Okay. Do you want me to talk about this, or do you want to just look at it? Any questions about